Hello, so today we're going to be graphing exponential functions. I know that sounds so fun. So in class we were talking today a little bit about the exponential function and its graph. And we talked about whether or not an exponential function was exponential growth or decay. Okay, so we talked about growth or decay. Now, when we talked about that, we said that these exponential functions would be in the form y equals ab to the x power. And we talked about what that b term means for us. So b tells me if it's exponential growth or decay. And it would be growth if the b term is greater than 1. And it would be decay if it was between 0 and 1, so a fraction less than 1. And the a term, as long as it was in standard form, always worked out to be a really important point on the graph, the y-intercept. So today we're going to be graphing those, and these really aren't all that hard. I'm going to go ahead and ask you to go ahead and put the coordinate plane in the graphs that I gave you. I didn't give you a lot of space to do that, so I apologize. These were old graphs that I had. And so we have our xy coordinate plane. Mine's a little crooked. And the first thing we want to do is we want to look at it and recognize that it's an exponential function because the exponent is an x. And so then I like to identify whether or not it's growth or decay. So I look at the b term. It's greater than 1, which tells me it's exponential growth. So that means from left to right, I know this graph is rising. Okay? And we can even put because b is greater than 1. The next thing I like to identify is the y-intercept, remembering that the y-intercept is where x is equal to 0, so it works out to be 0, 3. All right, the domain we've been talking about, there's no restriction on the x value this graph can be, so the domain for an exponential function will be -infinity to infinity. And we know that the range has something to do with that asymptote, that funny word we talked about. So as a reminder, an asymptote is a horizontal line for an exponential function, and it's the line that this graph gets really close to but can never touch. In this case, the asymptote is y equals 0, and I draw a dotted line, a horizontal dotted line going through 0, like that. Okay? So there's my asymptote. All right, so now I plot the point, the y-intercept 0, 3. So it's right about here. But I actually need 2 other points on the graph. So I'm going to make a table of values, and I'm going to actually use -1, and then I'll put that 0, 3 in there, and 1. These are nice, easy points to use. You could use bigger points if you wanted to, but you don't really need to. So when I plug in -1, I get 3 times 2 to the -1 power. All right, remember that 2 to the -1 power means you flip it, you bring the 2 down, so it would be 3 times 1/2. 3 times 1/2 would give me 3/2, which is 1.5. Okay? So 1.5. Now I put in 1, sorry I'm running out of space here, 3 times 2 to the 1 power, 2 to the 1 is 2, 2 times 3 is going to give me 6. Okay, so now again, we talked about the growth and decay functions today, kind of what they looked like, but we're going to plot these points and make sure that we know what they look like. So at -1, it's 1.5, and at 1, it's 6, so off the graph, so somewhere up here. Okay. Now remember, the graph has to get as close as it can to the asymptote, and it's growing from left to right. So it's flat, 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 starts to rise, starts to rise, starts to rise, goes through the y-intercept and shoots up. And there's the graph of the exponential function, of exponential growth. All right, let's look at a different one. So y equals 3 times 1/2 to the x power. All right, so this is different. Now this one is similar but different because this one's decay. Why? Because b is between 0 and 1. It's a fraction that's less than 1, okay? All right, so again, my y-intercept is still the a term, so 0, 3. My domain remains negative infinity to infinity because there's no restriction on what x can be. The range, again, relates to the equation of the asymptote. The asymptote is a horizontal line through 0. I'm going to go ahead and get in my xy coordinate plane here. X and y. I'm going to draw in my asymptote, a horizontal line, in this case going through 0. Now eventually that's going to change, but for now y equals 0. That tells me my range has to be y is greater than 0 because it's going to be above that line, all the y's. And then I make my table of values. I already have the point 0, 3, and we're going to pick those exact same x's, negative 1 and 1. All right, so if I plug in negative 1, I get 3 to the 1/2 to the negative 1. Okay, so a fraction to a negative exponent means we flip it and make it positive. So it becomes 3 times 2 to the 1, which gives me 6. Then I do 3 to the 1/2 to the 1 power, which gives me, similar to that last one, 3/2, so 1.5. All right, so I'm going to plot those points. Let me switch to red here. I've got negative 1, 6. So again, it's off the graph. It's somewhere up here. I've got 0, 3. So 1, 2, 3. And I've got 1, 1.5, right about there. Now again, this is falling. So it's taking a really sharp nosedive down, 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 going through those points and then flattening out as it gets as close as it can to that asymptote. And again, it's a nice curve, even though my graph isn't looking like such a nice curve on my page right now. And there is exponential decay. Exponential decay. All right, so those are the basics of the graph. Let's throw in one more component. So now we're going to be looking at a function when I put a negative in front of it. So just like all the other ones that we've talked about, the square root function, we put a negative in front of it, the quadratic. That negative in front of the function reflects it. Now I'm going to put this under the verbal description. It's going to reflect it over the x-axis. Reflects it over the x-axis. So it kind of flips it over the x-axis, okay? All right, so we go through the same process. We determine if it's growth or decay. And just because there's a negative in front doesn't change any of that. That 2 is that b term in the form y equals ab to the x. That b is greater than 1, so it's going to be exponential growth. Why? Because b is greater than 1. Again, that negative in front is going to reflect it over the x-axis. I do still want my y-intercept. My y-intercept is going to be 0, -3. Okay? So yes, you do have to be careful now because my y-intercept has become a negative. All right, my domain doesn't change. There's no restriction on my x values, so negative infinity to infinity, all real numbers. Now, we've got to talk about the asymptote. The asymptote, the equation of the asymptote is still that horizontal line of y equals 0, but the graph's now going to occur below it. So I drew the lines in there for you, but I'm going to go ahead and now put in my asymptote. I'm going to talk about the range after I graph it. So there's my asymptote. That's that line that the graph gets really close to and flattens out and doesn't touch it. Okay, I'm going to make my table of values, my x and my y. I've got my y-intercept of 0, -3. I'm going to do -1 and 1. Okay, so we do -3 times 2 to the -1 power. Remember, that negative exponent makes that 2. It makes it a fraction, not a negative number, so it becomes 1/2. So I get -3.5, or -3/2, sorry, -3/2, which is -1.5. Okay, all right, and then I plug in 1, so -3 times 2 to the 1 gives me -6. All right, I plot my points. 0, -3, so down here. -1, -1.5. And let's see, x is 1, y is -6. So 1, 2, 3, 4, 5, 6. All right, so now, as you can see, like what I'm doing is I'm going to be growing, but I'm starting on the left and I'm going like this through my points. Now, remember, when we did y equals 3 times 2 to the x, it looked something like that. So you can see that, and actually let me redo that. You can see that it was literally rising like that. So you can see now that it is the reflection over that over the x-axis, okay? Now, it doesn't really look like growth or decay. So that's the thing that is kind of funny. Once I flip it over, kids want to think this is decay, but it's not really, okay? All right, so that tells me that my range, my y values to the graph are going to be y's less than 0. Remember, it's just less than. It doesn't equal because it cannot equal 0 because it can never touch that asymptote. All right, so hopefully that was a nice introduction for you into graphing the exponential function. And we're going to be practicing this tomorrow in class, so have a great day.